All right, so thanks everybody for joining. Super excited to be here with Christina Taylor, data engineer in the Toptal network. First, to introduce a little bit about myself, VP of Enterprise Sales at Toptal. My name is Matt, and I think Christina's background, frankly, is a little more interesting than mine. She's worked at Disney Plus, Carvana, and a couple of other places more recently on the data and engineering side. And so we'll let her give a brief intro of herself.
Yeah, sweet. Thank you, Matt, for the intro. And my study background was data science. Being a data engineer was actually my second life. Originally started in the education industry, but I've worked in ad tech, streaming, media, entertainment, fintech, and e-commerce. More recently, enterprise software. So a long journey and an illustrious list of employers and enterprise Databricks customers. Very excited to be here and as Toptal's honored guest.
Awesome. Thanks, Christina. And I think, like a lot of the talent in our network, the engineers, designers, et cetera, a varied background across different employers and different skill sets. So with that said, we will talk about some of the themes that we're going to address today. First is Toptal and what we can do in kind of the digital and business services realms. And then, of course, it's a Databricks conference after all, so we'll talk about some specific topics in the data and engineering realm, data and analytics, data science, and particularly the Databricks platform. Before Christina will get into a couple of specific challenges that organizations face in this space, and multi-cloud data streaming. So I'm not sure if you wanted to say any other preamble, Christina, before we dive in, but those are the topics in the back half.
So from my experience with all the different industries and enterprises, what I've come to realize is, although it's very ideal if you could consolidate your stack into one single cloud and region, that is not often the reality. And there are all sorts of reasons why each organization might have chosen your favorite cloud and tools, but most enterprises today are multi-cloud. And increasingly, we want to build open, low latency, multi-cloud data systems. What are some of the considerations? And so we can scale to multiple clouds and make it suitable for all the data science and machine learning workloads. I'll be happy to give you some real life examples today.
Awesome, cool. Well, before we dive into all of that, we'll start with some of Toptal's capabilities, and I know we're both familiar with Toptal, right? But how would you pose kind of the value proposition to someone who doesn't know Toptal? Like, actually, I'm curious, how did you first find out about Toptal in our network?
I think I started right a little before ChatGPT took over the world, and I don't know if it has the most recent information, but I did a Google search, and a bunch of sponsored results came up. Toptal actually not one of the first. I saw Fiverr or what was the other one called Upwork coming up first. And then I explored some of the opportunities on the network and the candidate pool. And I didn't feel at that point it was the best fit for me. And then I saw this promotion that, only the top 3%. So I thought to myself, do I challenge myself? Am I one of the top 3% of the world? So, and then upon looking at the specific opportunities, assignments, so I find this to be very compelling and just suitable for my interests and skill set. So yeah, maybe you can share with us a little more as a candidate or a freelancer. Why should I pick Toptal over these others?
Yeah, well, I think, so first, just to start off with a bit of context and background, we have different lines of business. So of course, we started in software engineering 10 to 15 years ago. That was how we got our start. That includes things like data engineering and analytics and data science today, of course, but also more kind of traditional application development. Then parlay that into UI, UX design, again, mostly in the world of application building, before getting into project or product management, and now on the commercial side, in addition to the technical, things like management, consulting, and finance. And I think what a lot of individuals on the freelance side really like about Toptal is the fact that, for the most part, they can work from anywhere, and they have access to an incredibly high caliber pool of clients. And I think it's the same on the client side with respect to the access to the individuals in our network. So as you mentioned, quality is one of our differentiating factors on both sides of the marketplace. So only 3%, actually less than 3% of the individuals who apply to be part of our network make it in. Congratulations. Harder than getting into Stanford, I think, among other places. And in addition to that, we have a curated kind of white glove service we put on top of that allows us to deliver for our clients in a way that's faster and more flexible than a lot of other competing platforms in the space.
just to recap, I'm gonna do a little bit of role plays here as well. As an
Sure.
organization, why should I choose the Toptal consultancy over hundreds of other competitors?
Yeah, so I think it's our ability to play across all the different models that our clients tend to use. So in some cases, it's staff augmentation. You just need someone for a short period of time on a contract basis. Other times, it's in a more kind of traditional services context where we're doing an end-to-end application development project or a cloud migration or something that's kind of more soup to nuts, and we can really do all of that at a high level of quality, speed, and flexibility. As opposed to other competitors that tend to do maybe one or a couple of the things that we do, but not all of them, and not with as much fluidity across that spectrum. So, yeah.
Okay, thank you for the context.
Sure, absolutely. Well, it wouldn't be a Databricks conference without talking about some of the related topics that we all have in the rest of the sessions this week. Among those are data engineering, data science, and then of course the hot topic. It's felt like more like a series of rock concerts to me here sometimes than a business conference, but artificial intelligence and specifically generative AI, large language models, machine learning. These topics, of course, are at the top of everyone's minds today. And I think a lot of this starts on the left-hand side of this, right, Christina, which is where you have a lot of experience and where you do potentially work with our clients in our network. On the data engineering side, what sort of challenges, do you see individuals such as yourself in our network solving for clients when it comes to data engineering?
I think it's important to keep in mind that the Databricks platform really consists of three major personas. Even though the overall theme is a unification of the three. So there's a data engineering persona, the Databricks SQL, aka Analytics BI persona, as well as the AI and machine learning solutions. And what makes the platform so interesting is that its capability to accommodate all of these. And you can do analytics where your data is. You can service machine learning use cases on unstructured files where it's all collocated in the data lakehouse. And the architecture really focuses on openness and interoperability. And why is that important? And then we'll get to it when we talk about the multi-cloud nature of today's platforms.
Yeah, I think that's a great summary, and don't want to tease the audience anymore before we get into a couple of your technical topics. Of course, goes without saying, Toptal can do work across all these different domains with individuals such as yourself in our network, and we have over 700 individuals who have various skills and certifications in the Databricks ecosystem. So, highly qualified talent pool ready for our clients in this area. But let's get to the topic of today. I think multi-cloud usage across enterprise organizations is pretty much ubiquitous these days. Data coming in, as we've heard in many of these other sessions this week, from a multitude of sources, unstructured, semi-structured, structured data. And as data comes in from those different platforms, it can pose some challenges to our clients from an infrastructure perspective, as well as kind of the full life cycle of using that data and putting it to work in models and in other applications. So, I'm curious about your thoughts on multi-cloud streaming in particular, Christina, to kick it off before we delve into the landscape a bit.
Yeah, so I've already mentioned that most enterprises today are multi-cloud. So let's say if you are an early stage startup, you're not sure what you want to build yet, and you might have gone for the most amount of products or skills and enterprise support. So you might be on the dominant cloud. Or let's say you have a lot of microservices and you really wanted a best-in-class container service and customized Kubernetes, and or maybe like more advanced TPU to train your language models, then you're on GCP. Again, if you're a bigger enterprise, like a very strong Microsoft suite, or you have something that just batch loads a large amount of data, something that we all love and hate as data engineers, ADF, but you cannot get rid of, then you're probably on Azure. Or you could be like my previous employer, Carvana, that runs, quote, quote, distributed data mesh, and each engineering organization pick their own cloud and technology. Now, here we are. I want to show you something called MAD, shorthand for Modern Data and AI Landscape. I can't see it, can you? That is intentional. The landscape is increasingly crowded, and each day a new data source and vendor gets added, and sometimes it's integrated with a specific ecosystem, a format, a cloud, and creating silos and barriers between your data. So I don't know, Matt, when you look at it, what are your observations?
My observations are not much, because like you, I can't read it. And I think it's obvious to everyone here, probably who uses some of the logos in these charts, that even this is probably not an exhaustive view, as close as it is probably to anything that exists out there of one. And so that's where I think the flexibility from some of the open source technologies that you're going to talk about, Christina, can really help clients. But this is an overwhelming place to start. Let me speak at least from the commercial or the business side of things, which is why we have data engineers such as yourself. But let's talk about some of the specific things that make an environment like this a challenge. So you mentioned already the fact that most organizations maybe not are quite so complicated, right, as the map that we just showed, but to some extent are in a multi-cloud environment with data coming in from all over the place. So what challenges does that present, and what sort of design considerations might you consider?
Right, so since most enterprises today are multi-cloud, so when choosing vendors, platforms, technologies, try to find a way to avoid specific cloud and vendor lock-in. So my go-to is always prioritize on open source and open format. Thus, you could avoid the very costly data extraction from one format into another, and a huge network egress consideration when you go across clouds. I'll give you a very specific example. So my old team used to have a job that exports data from GCP BigQuery into AWS for another team's analysis. It looks pretty harmless. It's just a nightly job, right? But when looking at the cloud bill, we really discovered three major components to that innocent notebook. And so the first one was extracting data from BigQuery, so like something from Bigtable, $5 per terabyte. And then the second component was extraction from AWS into GCP. That's using the Spark BigQuery streaming read API. So it costs you about like a dollar per terabyte. And the last one is network. So since we're going both across cloud and region, we ended up paying the equivalent of shipping data from anywhere in North America to anywhere in the world, with the exception of Australia and Asia. So literally from edges to edges, that's about another dollar per terabyte. And all we know is a 2 terabyte table. It's puny data in today's world, but it's about 200K a year for us to do this cross-cloud export. And we used to joke, like, we shut the job, by the way, but among my old team, we used to joke that you could literally hire somebody full-time who just does this for a living, get him like medallion status on, I don't know, Delta Airlines, or excuse me, maybe it should be JetBlue after hearing today's talk. So like a hard disk in hand, just fly him from US Central 1 to US West 2, right? Back and forth, problem solved, no data engineers needed, better than co-pilots. So the point I'm making is choose an open format whenever you want to, and if you must, ship data across the cloud, considering a lighter weight messaging system. I'll give some specific examples from an architectural perspective on the last slide, but just to recap on the design consideration here, see if you can find a way to develop for both batch and streaming solutions. Spark Structure Streaming API provides such an interface. Of course, it's not the only one. Flink has that unified API as well. The last part I also feel very strongly about is infrastructure by code. So as you scale up to multiple clouds and environments, it's mission critical, in my opinion, to have source control of both your code and your infrastructure. And we'll get to more of that when we discuss the machine learning operations. But okay, we can move on to the examples here.
Okay.
So you see here we have our legacy architecture, application into data warehouse, migrating across cloud and region into some other teams, AWS. Okay, so maybe a typical workflow, but because of the cross-cloud and egress in nature, this is a very expensive pipeline. We had since then replaced with hybrid architecture, in that even within the Google Cloud platform, you could choose PubSub as your event messaging bus. You could choose cloud storage and open format. In our case, it was Parquet. At least you can have your data stored in cheap and open format. And again, if you must take it across the cloud, it could be inevitable. But at least we'll only have to worry about the egress, and not the extraction or the streaming rate, so to speak. So again, my 2 cents, always favor open format, so you can eliminate the data extraction costs, and you prevent yourself from being locked into a specific technology and one vendor. Prefer open source technology, something like Apache Spark, so you have the growth, the flexibility, and control. When you don't understand something, you could actually go to the source code and look at it and how it works under the hood, and go to the GitHub page and yell at the contributors, hey, please fix this. You could contribute as well, and especially in some of the larger enterprises. So the folks who try to reinvent the wheel, and something that open source have tried to build in the last 50 years, and what seems to end up always happen is that organization ends up contributing to the open source technology. Like Apple, for example, they're great contributors to Spark, so they can extend the open source framework to fit their own use cases.
Yeah, and I think the whole Databricks ecosystem being kind of open source at its foundation, right, enables a bunch of those tools and engines to kind of be built on top of that interoperable framework. So I know we're going to talk about a couple of tools particular to the Databricks ecosystem. The first challenge that we're trying to solve is around reliability and scalability. So obviously everyone here this week is talking about generative AI. And I'm curious, Christina, your thoughts on how organizations can best use AI tools to manage their data. What are some tools that Databricks has, and how might engineers use those to help them manage that data?
Where do I begin? And I think the Databricks machine learning persona offers almost like a full cycle platform for your ML use cases. And when we think about like machine learning operations, so that's the language, framework, platform, and infrastructure, and all these practices that helps data science teams to design, develop, and maintain their machine learning applications. So I want to show you something that I got from CRISP ML. That stands for, cross-industry standard process for the development of machine learning applications with quality assurance methodology. Okay, too much of a mouthful. Just think about it as like open standards and components to your entire machine learning lifecycle. And Databricks has solutions for many parts of it, but today, in the interest of time, I just want to focus on 2 areas that I have a little more experience with. Again, not trying to pretend to be a data scientist. Somebody else did all the cool and data discovery and training stuff, and I, as a machine learning engineer, so want to make their job of taking this to production and scaling it to multiple environments under clouds a little easier.
And there's a cool tool I think that Databricks has available for that. Of course, this looks like a lot for me, so I think it's helpful to focus on maybe just a specific part of the ML ops stack, which is model deployment and prediction serving, and ML flow recipes, which you're going to talk about.
Yeah, so I'm using ML flow recipes as an example of how iterate and deployment of quality models on the Databricks platform can be very simple. And the important thing is actually the idea instead of like the specific framework itself. Because ML flow recipes is fairly opinionated, so it provides you with these YAML configuration files where you can plug in and play with your own different steps in the model deployment. So for example, here we have the different steps outlined, from data ingestion, transformation, training, evaluation, to even register and predict the model. So this is all predefined for you. All you have to do is to edit a YAML file and put in some parameters and tell it what kind of data cleaning you want to run and how you want to store your predictive outcome. So it provides a convenient way for data science teams to source control your code, data, plus configuration very quickly. And again, the idea is even more important than the technology itself, because I believe this is actually what the Mosaic team, very excited about the acquisition, does very well with large language models. So for MLflow recipes today, we're doing this for classification and regression. So some very simple, opinionated, basic ML models, but the same idea extends to LLMs. So what do you think?
Yeah, I mean, even as a non-technical person, I can largely parse what's happening here across ingestion, transformation, training, et cetera, which of course is great. But deployment and prediction serving are just a couple of pieces of this overall landscape. Another really important thing is, as you think about kind of scaling this up, right? CI/CD, how you think about pipelines. There's other elements of this process, and frankly, there are other tools that Databricks has available to developers to help with this part of the process as well. And I'm curious, how you're thinking about that, Christina.
Yeah, and it's actually a quite difficult concept because there are a lot of tools, a lot of libraries, and a lot of things for the data science team to do already. So you add more, now you need to write tests. You need to put all of your code in repositories, and you want to be able to self-service on the deployment and running the job. So that's a lot. For a lean and data science team to manage. But luckily, again, allow me to introduce an example of how you can codify this infrastructure. There is an open source project by Databricks Labs called the DBX project. It's very simple and straightforward. It's just Python modules. So if you're a data scientist, you're probably not unfamiliar with it. So all you'll have to do is pip install DBX in your environment, and it generates a setup py file for you to specify your requirements, your dependencies. It comes with an out-of-the-box Python packaging solution, and again, a template for you to specify your machine learning job configuration. So this can work with any arbitrary notebook jobs or training workflow that you established. And what I actually also really like about this DBX project is the ability to easily define different environments. So in your workflows, you can concatenate YAML. So you can specify your permissions, your cloud compute, okay, what kind of GPUs do I need access for, and what are some of the Spark settings I want to put on my cluster, and what are the different tasks in this MLflow pipeline. So maybe my first task is pre-training, and the second task is fine-tuning, and the second task depends on the first one. It's pretty simple and straightforward. Again, if you can read it, I'm confident that it's not such a steep learning curve for the data science teams. Again, this is more like a concept than the specific tool itself. If you want to go really fancy, you can always use Terraform to manage everything. But the idea is having source control of the code and infrastructure is the only way that you could enable your teams to work more quickly, and you can scale across multiple environments and clouds.
Yeah, I would say maybe not all the way to English as a programming language, which per Ali maybe is where we're headed in the world. But again, yeah, pretty easy to parse even for my non-technical eyes. But most of the folks at this conference, and frankly most of our clients, are on the technical side of things. So wanted to close simply by saying if you're interested in learning more about Toptal's capabilities in data analytics and AI and working with great data engineers in our network like Christina, you can get in touch with us. Our booth is 817 downstairs in the exhibit hall. This QR code will actually take you to a landing page on our website that has information about some of the folks with Databricks background and experience in our freelance network. And there's a few names on here as well of folks, including myself, that you can reach out to about any needs that you have regarding the platform or data engineering, data science more generally. So thanks so much, Christina, for taking time out of your busy conference schedule to talk to us about a couple of cool open source tools from Databricks, and open it up for any questions if there are. Otherwise, happy to field them here in person as well at the base of the stage.